Hello everyone, I am Nireesksha and this is my teammate Yashaswini. We are the student of Department of Computer Science and Engineering, Artificial Intelligence and Machine Learning at Maharaja Institution of Technology, Mysore.
Today we are excited to present our project titled DevCrewAI, AI, Multi-Agent Software Development Company Simulator.
The main objective of this project is to demonstrate the practical implementation of a agentic artificial intelligence and a multi-agent system in a software engineering.
Our project simulates a real software development company where multiple AI agents collaborate to automate software planning activities such as requirement generating, UI designing, system architecture planning, development planning, testing, and documentation generation.
In today's rapidly evolving technology landscape, software development requires a coordination among a multiple professionals and involves a significant time and effort. Through this project, we are aimed to showcase how intelligent AI agent can work together to simplify and accelerate this process.
Multi-agent system, the system architecture, technical stack, workflow of the model, and the final demonstration, the working of our applications through the live project demonstration. So let's begin our project demonstration and the workflow of the model. So first let us know about what is Agentic AI. Agentic AI refers to intelligent AI system that can independently reason, plan, make decision and execute tasks to achieve a specific goal. Unlike traditional AI system that only answers questions, Agentic AI system can perform actions, collaborate with other agents and complete workflow autonomously. The key characteristics of agentic AI includes autonomous decision making, goal-oriented behavior, task execution, reasoning and planning, collaboration with other agent, workflow automation. Agentic AI is considered one of the most important advancements in artificial intelligence because it moves beyond simple question answers interaction and enables intelligent task completion. Our project follows a multi-agent architecture. Instead of using a single AI model to perform all the tasks, we divided responsibilities among multiple specialized agents. Each agent performs a dedicated role and passes its output to the next agent in the workflow. The agent we are used in our project is product manager agent, UI designer agent, software architect agent, developer agent and tester agent, and also the documentation agent where the product management agent generates the software requirements, user stories, and MVP definitions. In UI designer agent creates UI specification, screen description, and navigation structure. In software architecture agent design system architecture, database structure, and API plans. Developer agent generates development roadmap and project implementation strategy, generates README files, and complete project documentation. This collaborative workflow ensures consistency across all project artifacts and closely resemble the workflow of the real software development companies.
On to a system architecture and workflow. The architecture consists of five major layers. The first layer is a user interface layer, built using a streamlet which follows a user to enter the software project ideas. The second layer is a agent processing layer which contains all the specialized AI agents. The third layer is the Gemini AI layer which provides a natural language reasoning and content generation capabilities. The fourth layer is the output management layer, responsible for storing generated artifacts. The fourth layer is the output management layer, responsible for storing generated artifacts such as requirement documentation and architecture plans and testing reports. The final layer is a generated project layer, which organizes the generated project structure and documentation. The workflow goes like this: the first, user input, product management, UI designer agent, software architect agent, developer agent, then tester agent, documentation agent, and generated output. Each agent receives the information from the previous agent and generates a specialized output required for a software planning. Now let's take a look at the technology used to develop our project DuelCrew AI. Programming language used was Python. Python serves as a core programming language for our application. It was chosen because of its simplicity, extensive AI ecosystem, and strong support for a machine learning and automation libraries. User interface was built using a streamlit. It allows user to enter a project idea, execute the AI workflow, and view the generated output in a clean and user friendly manner. AI model Google Gemini 2.5 Flash. The intelligence of our system is powered by a Google Gemini 2.5 Flash. It provides a advanced natural language understanding and generation capabilities, enabling each AI agent to analyze the project requirements and generate a high quality software planning artifacts. AI integration Google Generative AI SDK. To communicate with the Gemini model, we used the Google Generative AI SDK. This SDK acts as a bridge between our Python application and the Gemini API, allowing the agents to send a prompt and receive a AI generated response. Environment management using a python.env. We used a python.env to securely manage the environment variables such as a Gemini API keys. This ensures that sensitivity credentials are stored securely without being hard coded into the source code. Version control using a Git and a GitHub. For a source code management and collaboration, we used a Git and GitHub. These tools helped us maintain a version history, track changes, and manage the project development efficiently. Finally, the application is deployed on a Streamlit community cloud, allowing it to be accessed online through a web browser without requiring any local installation. This makes the project easy to demonstrate, share, and evaluate. Together, these technologies form a robust and scalable platform that enables a DevCrew AI to simulate a real software development company using intelligent multi-agent collaborations. Now, let us move on to the live demonstration of our project. DevCrew AI Multi-Agent Software Development Company Simulator. This is the homepage of our application developed using a Streamlit. Here the user simply need to enter a software project idea. For this demonstration, we are providing the project idea as a build an e-commerce website. Once the project idea is entered, we click on the generated development plan button. Immediately after submitting the request, our multi-agent workflow begins its execution. Unlike a traditional chatbot that generates a single response, our system activates a multi-specialized AI agents, where each agent performs a dedicated task and passes its output to the next agent in the workflow. As we can observe on the screen, the execution starts with the product manager agent. This agent is responsible for understanding the project idea and converting into a detailed software requirements. It identifies the product vision, target user, functional requirements, business goals, and minimum viable product required for the application. Once the product manager agent completes its task, the generated requirements are automatically forwarded to the UI designer agent. This agent analyzes the functional requirements and prepare a complete UI design specification. It identifies all the necessary applications, screens such as a home page, product listing page, details page, shopping cart, checkout, next login, registration, and order confirmation pages, and it also defines the navigation flow between these screens to ensure a smooth user experience. Next, the software architect agent receives the output generated by the previous agents. This agent designs a overall technical architecture of the application. It recommends the appropriate technology stack, defines the backend structure, identify the core service and modules, and outline how the different component of the system should interact to build a scalable and maintainable software solution. After the architecture is prepared, the developer agent generates the complete development plan. It provides a structured implementation roadmap that developers can follow during the software development process. This includes a backend organization module wise implementation strategies and service preparations and overall project organization. Following this, the tester agent becomes active and this agent automatically generates the testing strategy for the project. It prepares a unit testing cases, identify the functional testing scenarios and validates the important software modules and recommend a testing practice to ensure the software quality and reliability before deployment. Finally, the demonstration agent compiles all the outputs generated by the previous agents into a comprehensive project documentation file. This includes the project overview, features, module descriptions, setup instructions, and implementation details, providing a developers with a complete documentation of the project. After the successful execution of all the agents, the application display confirmation message indicating that every specialized AI agent has completed its assigned a task successfully. Now let us review the generated output. The first output is the product requirement document, which contain the product vision, target user, detailed functional requirements, shopping cart functionality, checkout process, order management, reviews, and many other essential software requirements. The second output is the UI design specification, where all application screens, page layout, navigation flow, and the user interface element required for the e-commerce website are clearly defined. The third output is the technical architecture plan, which explain the overall system architecture, backend structure, development modules, and a service organization that will be used to build the application. The next section presents the development plan, which provides a developer with a clear implementation strategies for building the complete software project. After that, the test case are generated automatically. This includes the unit testing scenarios and validation strategies to ensure that every module functions correctly. The project readme is generated. This document summarizes the entire project, including its objectives, features, architecture, setup instruction, and implementation details, making it easier for a developers to understand and continue the project. This entire workflow is generated automatically from a single project idea without requiring a manual planning or a documentation. Through this documentation, we can clearly observe how multiple AI agents collaborate, exchange the information, and produce a well structured software engineering artifacts.
In conclusion, DevCrew AI successfully demonstrates the practical implementation of Agentic AI in software engineering.
The project automates the software planning activities through the collaboration among the multi-intelligent agents. It reduces the manual efforts, improves the planning efficiency, and generates a consistent project documentations.
The system showcases how Agentic AI can be used to solve real-world software development challenges and represent a step toward intelligent software engineering assistant. Thank you.